Hey, 11s, thanks for coming along. I've got a couple online, and I've got most of mine in my live lessons. Say hello, everybody. Hello. There you go. That was a terrible hello, wasn't it? Well done. That was excellent. Right, let's share our screen and crack on. So share screen. Okay, so we're picking up. This is organic. I don't need my screen because I haven't got my clip cam, and there it is. Okay, I need just to check that it's all running. I've got that over here. Right, let's share our screen. There we go. That's working just fine. I will say there's no point in contributing on the chat because I can't look at the chat because I'm sharing my screen in the classroom. But just letting you know. Okay, so nice, easy lesson today. So this is, as I said, Alkenes lesson 1, but overall organics lesson 5. So the learning objective is know the reactions of alkenes. I think that seems reasonable. What can we add to alkenes? Number 2 is know the test for alkenes, and then understand the addition process. So, okay, first thing, I think it's been a week since I've seen you guys. Let's do a little bit of naming just for fun. Okay, so I'll leave my learning objectives there. Let's see what's my CPU running on, because I could probably turn it down. Turn it down? Is that a good idea? No, let's leave it in the middle. Okay, so let's just do a little bit of nomenclature. Nomenclature, which translates to what, Zach? What does that word mean? Nomenclature. It's a stupid word, right? Yeah. So I don't really like that word either. I think it's garbage. Just there's one word that it means. Wow. This is going well. Have you figured it out yet, Zach? Name. Yeah, naming. Nomenclature is literally a posh chemistry word for naming. Yeah, the way we name. So let's do some namings. And of course, we're doing alkenes. So let's use some alkenes. So I'm going to start off with Lynn. Lynn, I'm going to ask you, please, to name the most basic alkene for me. Please name him. Thank you very much. Love it. Ethene. I think everyone in this room is like, yeah, this is easy. Right, Zach, can you name me the next one, please? Name this guy for me. Just in all H's.
Do you have to say like the number?
Don't worry about it. Just give me the name. Don't worry about numbers. How many carbons, Zach?
3.
So it starts with? Thank you very much. This is a prop. Yeah. Well done. I love that you've given the number. Can I just say, Zach, you do not need to ever write down numbers in your exam at GCSE. So you can always just say propene. Oh, of course. I mean, that is. Can I just say, by the way, the one in this case. Now, this is one of the things when you do A level. So I'm doing naming, by the way, in the taster session. So you guys are going to be ahead of the curve already, which is amazing. In this case, you do not need the number. The reason being is the double bond can't go anywhere else because I'll just name it from the other direction. Agreed. But in A level, the students never get good enough to know when the number really does or doesn't need to be there. So the rule is just put it in all the time and you never go wrong. Does that make sense? So, but it's lovely, Zach, the fact that you're considering it is awesome. I love that. Propene. Right, let's by the way, at various points in this, I'll go a little bit beyond GCSE. I'm going to go to, let's go to Atia. Can you give me this one, please? Well done. Love the fact that you've given me the A-level name for that. That's amazing. How Ping, could you extend that at all? Well done. It's totally not required. This is part of AS Unit 2. That is actually a Z isomer, but you definitely not needed for GCSE, so I can just flat out ignore that. But it's nice. Well done, Halping. Libby, did you have it too? Well done. So this is butene. Okay, let's go for a next one. Let's go for, by the way, well done, actually. That was excellent. Imani, can you give me this one, please? Give me that one. All H's. Well done. Love it. Pentwanine. Good job. Wow, I'm being really good with my pentwanine. Love it. Let's go for the next one. Okay, I'm now going to give, this is for, let's go for libs. Libby, can you now give me this one, please? This is beyond GCSE at this point. But it's nice to do it. Libs? Well done, outstanding. This is based on prope. That's where the prope comes in. And then we go, oh, it's got an een in it, and it's between 1 and 2. So this is prope 1 een. But I now have a branch. And in chemistry, it's got 1 carbon in it, so it's a meth. But how do you say branch in chemistry? You add the "-ile", and this is on number 2, so that's 2-methyl prope 1 een. And if you're looking at that and going, I understand how that's being built, then guys, you're, as I said, way ahead of the curve. This is beyond GCSE, but it's so nice to have you doing it. Let's go for another one. I'm going to go for Caitlin. Can you have a go at this for me, please? Impress me. All H's. Well done. That is cycloprop 1. Don't need the 1, but it's nice to include it because it would be between 1 and 2. Wouldn't matter which way I go. Well done. Cycloprop 1 een. Put your hand up if you have it. Great job. That's great. By the way, that one can actually be asked. That one has been asked at GCSE. So that was cyclopropene. That one was asked. I'm now going to go for, let's go for Mel. Try this one out for me. Do you recognize how I've written it? Can you tell me what type of a formula this is? Well done. Say, yeah, skeletal. Yeah, skeletal formula. Do you want to have a stab at it? So at every joint, it is a butte. Well done. This is a butte. Yeah. Well done. Butte 1 een. Well done. Yeah, guys, it's nice to see a different. By the way, you are not expected to know skeletal formula at GCSE, but it is nice to see it. Don, but can you tell the shape? Oh, you can actually, yes. The reason being is, so that's a very interesting question. So Dom, that there is an E. The reason being is because the invisible hydrogens are on opposite sides from each other. Yeah, but the Z would look like this. Isn't that cool? So yes, you can. Great question. I really wish my A-level kids would darn well ask me that. Oh man, it's so lovely to. I've been teaching you guys long enough that you guys ask all these kind of questions because it comes into your mind. But the A-level kids are just like, oh. You come from different schools and I don't know what's going on. So it's nice to do a bit of naming. What a load of fun that was. Okay, so now guys, we now go to our first learning objective. Go on, let me zoom out. Why aren't you letting me move up? It's not letting me move up. Why isn't it letting me move up? It's not letting me, oh, okay, it's letting me move up now. No, it hasn't. Anyway, reactions. Okay, it's already starting to get a little bit wham on this tablet. Let's turn down the CPU a little bit further. Right, so bullet point number 1. Alkenes go through addition. Notice I'm even going to change my color. Go through addition reactions. Addition reactions. And it is actually, and I do love chemists when they make it easy. It literally means we add 2 enes. Alkenes have got this carbon-carbon double bond, and we know that it is possible for us, if I had let's just do the H's on the end of it, go back to good old ethene. We know that what we can do is we can break that double bond. We can break it, and each carbon will be able to join to new objects. Does that make sense? So we can add to them. The question is, what can we add? So there's a couple of things that we can add to alkenes. So first one, number 1, add, let's do bromine. We add bromine. Sorry, I'm going to rewrite that. Oh, uh-oh. Come on, laptop. Don't do this to me. Let's add bromine. I'm going to quickly ask Alison, what's the formula for bromine, please? It ends in -ene. Well done. We know that any element ending in -ene or -gen is diatomic. Let's turn it into a picture. We love pictures in chemistry. You guys all know here, I've said this so many times, I work entirely in pictures. I have no words in my head at all for chemistry, and then I just build the words based on the pictures I have in my head. So there's bromine. I'm going to ask, how ping? So first of all, if I had Br2 as a gas, what color would it be, please, Happy? Well done. So it's a brown gas. Next, if I then have Br2, I'll ask Kayla, as a liquid, what would it look like, please, Kayla? Oh, no, but I know where you're getting that color from. It's darker. It's brown as well. So it's a brown gas and a brown liquid. And then I can come back to Kayla again and say, what is it aqueous? Orange, well done. That's super important. Bromine water is orange. Mel, why? Why is the gas and the liquid so dark, but then the aqueous version being orange? Don't overthink it. Parts. Can you say it again for me? Less parts. I like it. Well done. This is purely down to the fact that we are diluting it with water. Yeah, you add water to it, it dissolves in the water and it becomes dilute and the color spreads out. Fewer particles per unit space. Would you agree, Mel? I felt like that's what you said before. That's why I was like, oh, that's kind of right. Fewer particles in the smaller area. So it's just dilute. Okay, so what we're now going to do is, let's add bromine to our alkenes. So if we now take our ethene, and ethene, by the way, is a colorless gas. All alkenes, by the way, are except once they get long enough. But it's a colorless gas, and I'm going to add, and you'll notice that I'm switching to the stick picture all the time here. So here's what I'd like you to do, please, Year 11. What am I about to make based on that? Everyone, you've just got 30 seconds. Draw my product. I'm kind of hoping you're going to figure this out. Look at the image I did before of the addition reaction, and then have a guess at what I'm going to make. See, this is when my YouTube lesson becomes incredibly boring, because everyone watching is like, what's going on? That's interesting, because you've lost the way. And here's right. Thank you very much. Look. Oh, by the way, is it you say EP? Oh, love that. Do you see what I mean by those students don't remember when they do need them and when they don't need them? So just always give them all the time. If you're ever adding something on, sticking the numbers for it. Well done, you're so impressed. Right, guys, let's see how many people got it. So the point of this was that it was this bit. We realized that when you add to an alkene, you've got to add to both of them. And the picture makes this super handy because we can see we're adding 2 BRs to this. So the outcome, and I'll have a quick show of hands, put your hands up if you had this. Yep, so we had 2 bromine atoms in the bromine over here. Put your hand up if you had it. 1, 2, 3, 4. Oh, look at that. I thought it's easier to say who didn't have it. Amazing. Well done, guys. So alkenes, we can add to them. And by the way, this is important because this is actually the chemical test for the alkenes. So we can write this down. I'm going to put it in a nota bene box. Zach, you mentioned nota bene earlier. Oh my goodness. Zach never ever said that in chemistry. Oh, good grief. That's funny. I just told you never to say it and I use it all the time. What does it mean and what language is it in, Zach? How many times have I said this? Like Zach? It's not Greek. Oh, but it's Latin. Well done. For?
Important.
Well done. Good man. So we've got nota bene. So the chemical test for an alkene is bromine water. Yes, perfect. And the observation which we know they're going to ask for is orange to colorless. Love it. Do not say clear. Yeah, clear means you can see through it. You can see through the bromine water already. It's just a clear orange. Yeah, it's orange to colorless. You may also see on a mark scheme it says decolorizes bromine water. I prefer the real observation. It is what I prefer, because there are times when they push you into the real observation where they've actually said, alkenes decolorize bromine water. Give the before and after. And everyone goes, what? And you just have to say orange to colorless. They're checking to see if you remember the original color of bromine water. That's all. So we can add to alkenes. Right, let's make this a bit more challenging. What would happen? So this is reaction number 2. So we can add bromine water. Does everyone also realize, everyone okay, that I can also do an extension here and say, we could also add chlorine or iodine. And do you see, I don't need to write this down, do I? Yeah, we know that if you add a halogen to it, they go across it. This isn't rocket science, is it? So here's the next one. Number 2, we can react them with water. Reaction with water. Now this one, by the way, is actually a bit tricky. We have to do reaction with water with concentrated technically, I think they're going to want phosphoric with concentrated phosphoric acid catalyst. So this won't happen normally. You need a catalyst for it. But let's check out the equation. So we've got good old ethene again. Gotta love you, ethene. And we are going to add, this time, we're going to add water. Guys, now this is a real challenge. Draw me my product. That's going to be very interesting to see who can guess this one. It's just a little bit, this is going to take a bit of a leap of faith. Guys, just consider what you did in the previous one. And then consider, like, you'll need to go, there's a problem here. Have a think about it. Well done. You see, the problem is that, I actually had a kid off. I had some sort of half circle. I kid you not, I had someone do that once. I was like, are you fool? Like, it was very cute. I was like, wow, somebody did this in my, I'm not doing this on the YouTube bit. Someone did that. Sorry, someone did that. And I was like, what? And they're like, I just split it in half and shut. Like, and I was a bit like, wow, okay. So you think that's a thing? Issues, major issues. Yeah, don't cut atoms in half. That's all I've got really. Okay, so let's do it out. Okay, so we've now got this guy, and we're forming our favorite Friday night molecule. Not that you guys have ever, tasted, smelt it. You guys don't know what this is, do you? Yeah. So now at this point, just to mention, it is reversible. Just so you know, this reaction is reversible. Yeah. So if that's reversible, Libby, so this reaction here is reversible. So the alcohol can actually turn back into the alkene. But if I want to make a high yield of ethanol, what would I do to the amount of ethene that I add to the mixture? You are well done. You're running COFC on this.
So it's reactant. So then the equilibrium will try and if you increase.
Well done. We're going to have a high conc of that. Yeah, add boatloads of this, push the equilibrium towards the ethanol. Yeah, I like it. If I now tell you that, Imani, what would I do to the pressure? Well done, spot on. So we've got, can you explain it to me? Well done, you've said high pressure. This is absolutely correct. High pressure. We actually use, by the way, 60 atmospheres for this. 60 atmospheres. That's pretty high. In a deodorant can, there is 3 to 4. Yeah, a deodorant can is about 3 to 4. In a car tire, there's something similar. Amazingly, but 60. I mean, this is. If you go diving, that's 600 meters underwater. Yeah, this is high. So can you run, Imani? Can you run it for me? Run COFC. Okay, you've just unfortunately dropped into kick-ass. I know, this is the problem. Yeah, you've got to make sure that you separate COFC and kick-ass very, very clearly. By the way, you did something interesting. So you did the knowledge. So can you give me the knowledge for the equilibrium one? You've just given me favors. Do you see what it's just, this? Unfortunately, they do all need practice. Go on, Alison. Well done. How many moles of gas on this side? Dom, shut up. I'm on YouTube live here. I'm telling you to shut up. Sorry, Alison. Well done. We have 2 moles of gas. 1 in there, 1 in there. 2 moles of gas on left and 1 on right. Right, oppose. Imani said increase pressure. The equilibrium, therefore, will lower the pressure. It will do that by favoring what, Imani? Yeah, favor side. Keep going, ... I like it. Favor side with less gas. With less gas. Shift. Well done. At that point, we're saying left to right. So shift left to right. Ethanol increase yield. Yeah, ethanol increase yield. Yep, well done. Great job for saying high pressure. So we can make, guys, just imagine that. You can make ethanol from alkenes. So hang on a minute, let's think that through. Because where do alkenes come from? Alkenes come from cracking alkanes. Where did alkanes come from? They're dead dinosaurs. So we take a dead dinosaur, shove it underground for 60 million years, it becomes an alkane. We take that alkane and we crack it to make alkenes. And then we add water to that alkene to make ethanol. And then we get drunk on a Friday night on dead dinosaurs. Wow. Like, guys, this is a thing. All of the cheap alcoholic beverages that you buy, all the alcohol is made this way. Because it's cheaper than making it from fermentation. You don't want to ferment stuff for weeks when you can make it in 60 seconds in a machine. Yeah? So people are out there just drinking dead dinosaurs. Isn't that weird? It's actually dead dinosaurs infused with water. See what equation? Yeah, I'm going to move on with that. Suddenly realized Still live on YouTube. Not the best idea. So, number 3 reactions. Oh my god. Number 3. Addition, polymerization. Oh my goodness. Right. So this is reaction number 3. So I'm going to ask, Caitlin, since you're talking. You know this making my YouTube lesson? I mean, they're watching this live lesson and thinking, he's a terrible teacher. Terrible teacher. Can't even keep control of his own kids. Good grief. So, first thing is, Caitlin, poly. What is that guy? Well done. Great job. The word poly means many. Then we can go atia, mer. And if you say one of the gifts from 3 wise men, which I had once, I'll be very upset. Please don't do that. So if I said mermaid.
Oh, water.
Okay, let's try that again. Maybe slower. Mermaid. And then merman.
Yeah.
Yes, what does the mer mean?
Come from the sea.
No.
Mer, like emerging, like like more.
Funny enough, merging is actually correct.
Wait, really?
Yeah, annoyingly, but it's not a good example there. Would you agree the mermaid and the merman are the opposites of each other? You've got mer-woman, merman. Yeah. So what word would go in front of that? Because I could understand, and if you have them, I know that you're saying in the sea, get it. What if I added to the man and the woman?
Tail.
Thank you very much. So I would have forgiven you for saying fish.
Oh, is it a fish?
No, it's not fish.
Okay. I'm very confused.
I'm really not helping the scenario here at all. Did you say a solution? Are you dissolving the poor mermaids into water? That's really mean. What are they soluble in? They're definitely not soluble in water. That'd be a disaster. Although maybe they are, because they don't. Yeah, I've never seen one. Maybe they have just dissolved. I don't know. Thank you very much, Kaylin. The word mer means part. Yeah, part. So in this case, polymer means many parts. Yeah. Does anyone know what the opposite of poly is? Well done, is correct. So the opposite of poly is mono. So in this, what we can say is we can take ethene, and this is what we call the monomer. This is a mono, meaning one, and part. So one part. We can take a monomer. Let's take another one. Let's take another one. Another one part. And we are going, and let's stuff it. Let's go for 3. Let's go all the way. Let's just really annoy you guys with the pictures. So we've now got 3 monomers. Guys, put them together for me. Put them together for me. What is that going to make? Now that's clever, isn't it? Oh, Caitlin's really thinking about it. I like it. What am I now going to make? Ooh. Can I just give you one, please? One thing that's important here, guys. How many bonds? Ryan, how many bonds does hydrogen make? Thank you very much. Everyone needs to make sure you know this. Hydrogen never, ever makes more than one bond. It can't. That is impossible. First shell holds 2 electrons after one bond is gone. So what are those 3 going? Oh, she solved it. She solved it. Oh, I think Amani's on it too. Nah. That's smart, I think. String together. Isn't it clever? I'm even really impressed. Okay, that's not round.
I was this one.
Oh, that's fair enough. If you add this, I'll be happy. No, actually, it's actually quite important that you do.
I wouldn't think that.
No, I know that. Just put one now to show you that there's that is never allowed. These things, I know what you're doing. So, what does the picture tell me? It's saying, I am made from repeating this. Well, you're repeating that. It's not made from. There must be two in that bracket, minimum. Does that make sense? Yeah, because you didn't make it from that. You made it from that. Yeah? No, that's why it's important. Oh wait. Equal sign, Alison, in chemistry, please don't do that. They don't exist in chemistry. Actually, that's not true at all. Guys, let's see if everyone got it. So here's the clever bit. The double bonds break open and they string together. And what now happens, and this is the important bit. Guys, this is important because you don't get any more hydrogens. You have these open-ended sticks at the end of it. These here are blanks, which is very odd in chemistry because you're like, hang on a sec. You never ever leave a stick blank like that in chemistry. But the reason being is in reality, we're not going to have joined 3, are we? We're going to have joined 500,000. This chain will go on indefinitely. If I keep feeding it an alkene, it'll keep growing. These chains are thousands of monomers long. Can I just point out, we can make ones with millions. Yeah, they just keep growing and growing and growing. But in this case, we have got, so what you have drawn now is your very first polymer. Yeah, this is, and it's been made from 3 repeating units. Now, would everyone agree that this seems like a ridiculous thing to do? Because if this is made from millions, thousands, if not millions of these units, how could we do one picture that represents any length of chain? The way that we do this is by drawing only 1 repeating unit and putting it in a bracket with the letter N. It just means I'm going to join this together. You realize, by the way, that the lines here are going through that bracket. That's actually really, oh, my tablet is just overheated. So it's going through the square bracket. But this is saying that we can have any length of these. And it'll just go on and on and on. We form these giant strings, giant molecules making the same thing over and over and over again. Well, you can't have that, well, methane doesn't exist, does it?
Oh, sorry for protein.
Right. So Libby's asked a really lovely question. I know that, by the way, it's lunchtime. I apologize for you. This is Libby's fault now. So let's look at propene. Now, the thing with propene is we tend to draw propene like this. Now, this is going to cause a problem because what we realize, would everyone here agree that that can't make any more bonds? Yeah? The 2 carbons that can make new bonds are this guy and this guy. So what now happens is it's actually far better to draw it like this. Because what's going to happen is the double bond is going to snap. These will come out and it will then form a connection to another one. Does that make sense, Libs?
Yeah, I realized I wrote it down.
So here's an important fact for you. Do you know that square bracket trick? And you did the 1 carbon. In reality, what you realize is there is only ever 2. That is always correct, because what you're then going to do is put on the other bits that were joined to those carbons with the double bond. Does that make sense? Yeah, really clever. It doesn't, so here's PVC. PVC started life as chloroethene. That was PVC, and then you get this picture with the there's PVC. Used to make pretty much every pipe out there, and of course certain materials. Fake leather is PVC. Certain clothing as well are PVC. Shoes, example. So by the way, put it in a bracket and N. There's PVC. If you want another one of interest, here's. Can anyone name me another polymer? Another poly. Often used for packaging for your items at home. Styrene. Here's styrene. This is what styrene looks like. Funky stuff. Oh, my laptop's overheated. Here's styrene, otherwise known as, proper name, phenylethyl is the correct name of that now, but common name is styrene. So all you do is go, oh, hang on a sec, just break the double bond, put 2 in a bracket, and then add on the pieces that were there to begin with. Does that make sense? There's polystyrene. Yeah. So polymers aren't complicated because you just find the double bond, put 2 in the bracket, take these outside of it like that. Anyway, anybody else got any other questions regarding polymers? Want me to draw any of them up? I might not know them all. They're gone. Yes. They are alkanes that were made from alkenes and go on almost indefinitely. Yes, and this is why they're solids at room temperature. They're hard wearing. Your clothes are all made from them. Okay, well, depending on the clothes you're making, they might be polyesters or polyamides. You can draw a couple of those as well if you like. But all of your plastic bottles are made out of these. They've got high melting points. They're giant structures and super handy. Guys, I'll see you all next lesson. Have a great rest of your day.
Thank you, Mr. Jenkins.
You are more than welcome. Have a nice day, everybody.
Thank you.
Bye, guys.